In this video, I'm going to go over how to do some very basic calculus on the TI-84 graphing calculator. Calculus basically involves two procedures: the derivative and the antiderivative, or the integral, and related topics. Basically, it's two types of problems that you encounter. And the complexity of the problems you solve is going to depend on the functions that you're dealing with. So let's look at the first one that I have here. And I'm assuming that if you're viewing this video, you've already had some topics in basic calculus. But here we go. Solve each of the following in the TI-84 graphing calculator. So you're given a function: y equal f of x equal to x squared plus 2x. Okay. Now you can have a more complicated problem involving logarithms or trigonometric functions, or more complicated ones that involve some more difficult formulas. But I'm going to compute this first without the calculator. So I'm just going to say, okay, you want the derivative first. So first we take the derivative using the very basic formula. So the y prime, or f prime, if I use the f prime, or if I use the dy over dx, they all mean the same thing. So y prime, if the function is y equal f of x, then y prime will be the same thing as f prime of x, which will be the same thing as dy over dx. There's just different symbols for the same thing, the derivative of the function. You can have a double derivative and so on. Basic idea is, if you have a function and you take the derivative, that function is that derivative is a function also. And it actually represents the slope, or it gives you a formula for computing the slope of any tangent line to a point on the curve. Now, depending on the function, it could also represent velocity, or if you're taking, say, a second derivative, it could be acceleration. It could represent some other things. But here's the way it works. Y prime, then, if I use just the basic formulas, or I could use f prime. Okay, so it would be 2 times the 1. So if you have a polynomial, it's just 2 times the 1, the coefficient, that's 2. Subtract 1 from the 2 here, that's 1. So this would be 2x to the first. And do the same thing with the next one. The exponent here is to be a 1, so it's 1 times 2 is 2. And then we subtract 1 from the exponent, that gives me x to the 0, which is 1. So basically the derivative is going to be this right here. Now there's some calculators like the TI-89 that will give you a symbolic answer. In other words, it would give you this if you want to compute the derivative. It will give you this. The TI-84 only gives you numerical answers. So if I want to find the derivative, which is the case here, at x equal to 1, I would do it like that. Or I would use this function with a 1, or this one. Okay, different notations for the same thing. So put a 1 where the x is, I get 1 times 2 is 2, and 2 is equal to 4. So this is actually the answer here. Now if I were to graph this curve here, f of x equal to x squared plus 2x, then when x is equal to 1, put a 1 here, 1 squared is 1, 1 times 2 is 2, and 1 and 2 is 3. So that means at the point 1, 3 on that curve, the slope of the tangent line to that point is 4. Okay. So now, answer is 4. Okay. Now let's do it on the calculator. So on the calculator, we simply enter the function. Okay. So I already have it entered there. y1 is equal to x squared plus 2x. Select it, so let me select it. Hit enter, now that one's selected. So now I hit a graph. And there it is. Okay, so when x is equal to 1, y is 3, so somewhere over here, the tangent line that touches that point 1,3 right here. Okay, so the line would go something like that. Would touch this parabola at the point 1,3, and it would have a slope of 4. So the way we find it on the calculator is I hit the second key here, and then I hit trace. So I'm accessing calculate menu, so hit that. And then I go to number 6, that's the derivative, dy over dx. Remember, that's one form of the derivative, or one way to denote the derivative. So I hit 6 because I want that. Okay, and then x is equal to 0 is the default, but I want the derivative at 1, so I enter 1. And then hit enter. And there it tells me the derivative is 4. Okay. So again, in this particular case, since I'm dealing with a regular function, it represents the slope of the tangent line. There's the point 1,3 right there, right here. So the tangent line would go like this. It touches the graph at the point 1,3, and it'll have a slope of 4. Okay. So this is 4 right here. Okay. Let's clear this. It says find the value of the given integral. Find the value of the given integral. So this is just the opposite of the derivative. You take the derivative of a function, you get another function. And then you take the antiderivative, which is the integral, and you get back the function. Okay? So if I was just looking at this right here, we saw where the derivative of this was 2x plus 2. Okay. So if I want to find y, so if you're given y prime and you want to find y, then you would take the antiderivative. So this would be your function, f of x, and we would go through the formulas for finding the antiderivative, and that would give me this result right here, plus a constant. Okay, because the derivative of a constant is 0. Okay, so you're always going to have a constant unless you have specific limits of integration, which is what we're going to have in this next one. So let me clear this. Okay, so here's what we have. Okay, so the function here is x squared, or f of x, or I could just say y is equal to x squared. Okay, and the graph of y equal x squared would be this parabola. It has a vertex at the origin. And then this is the lower limit here, so this would be 0 right here. And then this would be 1, 2, 3. This would be the upper limit here. And basically this integral computes the area under the parabola and above the x-axis, contained within this space right here. So by computing this right here, I actually get the area under this curve. Okay, and that's one application of the integral, or the antiderivative, is getting the area under the curve bounded by the x-axis, this line right here. Okay, so how does this work? Okay, well, it's just the opposite of the derivative. So instead of multiplying here and subtracting 1, I add 1 to the 2. And then divide. So 2 and 1 is 3, and I got 3. Okay. Notice if I take the derivative of this, so this represents the antiderivative of this function x squared, but notice if I take the derivative of this, 3 times 1 over 3 cancels, I get this back. So the way it works is, now keep in mind, I'm doing this without the calculator just to show you how it works. So lower limit is 0, upper limit is 3, and then it works like this. You put 3 right there. That's 3 to the third is 27, divided by 3, minus the value of this function is 0. Well, 0 to the third is 0 divided by 3 is still 0. So this gives me 27 over 3, which is 9. So this is 9. So what that number represents in this particular case, it represents the area of this shaded section right here. 9 square units. Okay. If these marks are inches, then it's 9 square inches. But it represents the area right here. Okay. Now let me show you how to do it in the calculator. Now here I've got some basic, these are just basic functions, but like I said, you could have more complicated functions where if you're taking a derivative, it could involve the chain rule or the product rule, quotient rule, and some other formulas. But here we're just looking at the basic types. So let's clear this. Again, the answer to this one was 9. So put it there. Clear this. Let's go to the calculator now. Go to y equals. And I've already entered the function there. So let me select that one. So I need to deselect this one. So hit enter to deselect that one. And select the x squared. Hit enter. And then hit graph. Okay, so there it is. So again, finding the area under this region right here. Okay, just like I illustrated. So I go to second, calculate. Here I want the integral 7. And first thing, by default, it's set to 0. Okay, so I just hit enter. If it was from lower limit was 1, then I would type in a 1, but it's already 0 there, so I just hit enter. And then the upper limit is 3, so I type in the 3, hit enter, and it tells me the integral of that function is 9. And notice it even shaded it for you. So the shaded region there on the calculator has an area of 9 square units. And again, the units is going to depend on what units you're dealing with, inches, feet, whatever. Okay. Again, the answer to this one is 9. Okay. Just a short video on solving some basic calculus problems on the TI-84 graphing calculator. Thanks for watching. See you next time.